Hello, good evening to you lovely people. Thank you very much for coming to this session. We'll be talking about GraphQL Speaker, a Java library that promises the fastest route to GraphQL. And by the end of the talk, you can tell me if that's true. So first things first, what's GraphQL? I have to do a little crash course for those in the audience that might not know about it. So GraphQL is a query language for your API. So it's a way for your server, for your application to expose an API. So in this way, it's similar to REST. So think of REST for the moment. Unlike REST, it has a type system, which means that anything coming in and out of your system is strictly typed. In this sense, it's similar to WSDL and SOAP services, but unlike those, it also has introspection, which means that a client is able to find out everything about your system just by querying it, so without any additional documents or anything else. So in this sense, it's somewhat similar to how you to what you can do with a relational database. You can ask a relational system to tell you what tables are available, or what columns are inside a table, or what types of the columns, and so on. So you can just find this out as you go without knowing it up front. So this is the same thing here. It is based on specification, which means, so unlike REST, for example, that's architectural style more than a formal specification. GraphQL is a specification, which means that any compliant server will behave in a known way, which means any compliant client can talk to any server, because they know how they communicate. The implementation of that spec is a server-side runtime for executing queries. The implementations exist for any language you might care about. Of course, we'll be talking Java here, but for anything. So this is something that you get out of the box when you get GraphQL. So the part that parses the queries, that assembles the results back and all that, that's done for you. And just as a disclaimer, it has nothing to do with graph databases or their own query languages. So it's sort of just a naming misfortune. All right, so that's what. But why would you want GraphQL in your application? So it gives you certain promises that you might like. For starters, it gives you a way to formally describe data. So let's say you have a type, so query being the root here. So let's say we have a query that gives us a project based on some code. So we give it a code of type string, and it gives us a result of type project. Whereas project is defined as an object type that has certain properties. It has a code and description, which are strings, and it has a list of tasks. So then a task is further on defined as another object that has a status, it has a description, and it has related tasks. So the interesting thing to note here is how a task has a recursive relationship with itself, well, with other related tasks. So it shows you that you can model more complex relationships than just a simple tree. The second and perhaps the most important or at least most interesting promise GraphQL gives you is that as a client, you never need to under or over fetch, meaning that in one go, you always get exactly what you need, no more, no less. So the way that works is that client sends queries that look something like that, for example. So we can ask for a project with the code legendary. It's a fictional dairy shop that we're going to make later in the demo. And then from the project, you want description, and then you want the tasks, but only the ones that are ready, for example. And then from there, you all right, I'm back. So if you squint the right way, it sort of looks like JSON with no values, just with keys, right? And so from this, you can see the client is in charge of what gets fetched. So the client says that they only want projects that are, that's legendary, and they want a description and tasks, but they don't want for example, the related tasks and so on. So they choose what they see. And the third important promise is that the results will always be predictable in the sense that the shape of the result will always be exactly corresponding one-to-one to the shape of the query. So if you choose to look at a query as JSON with no values, then, well, the response will be the same JSON, but with values. So because the tasks was a list, there's multiple tasks in the result, but apart from that, the shape is exactly one-to-one. So here we get a project as we asked for, and then we get a description and tasks and so on. So what this does is it gives rise to a radically different architecture than what you're used to with REST applications. So normally with REST, you have your client hitting an endpoint. The boxy things on the picture are your endpoints. They're arbitrary codes, and they're usually large because they normally need to talk to multiple different backends, maybe third-party services, different things, storages, whatnot, and then merge the result correctly and send whatever they want to the client. Well, that's important, actually. They send whatever they want to the client, not what the client wants. With GraphQL, you get a very different picture, because what happens is that every one of these fields that you see here that a client asks for, the project, the description, the task, all of those are fields. Each of those fields is backed by a different resolver function. So behind every field, there's a function that is in charge of resolving its value and its value alone, nothing else. It can be as trivial as just calling a getter on some object, right? Or it can be as complex as calling third-party APIs and doing some processing and God knows what. But each function is in charge of resolving the value of an individual field. So what that means is that these little boxy things are much smaller, because now we're talking about very tiny little pieces of business logic that talk typically only to a single thing. You will very rarely have the reason to talk to multiple storages, for example, in one place. And then it's the job of the GraphQL engine, so the red thingy, to merge those correctly and assemble them into the shape that the client asked for. So you are in charge of writing the individual functions for resolving values, and then the engine's problem is everything else, calling them correctly and assembling the results. Okay, so that's all neat and dandy, and let's say you like it. How do you get to it? So this is the actual topic, the speaker library, which I'm the author of. Well, not the only author, but the main author of. And that should make this all very easy to get into your application. So let's start with something that you would probably already have in your application, like a service class that does something. So in our case, because we're talking about tasks and projects, so think of Jira-like application here. So we have some service that deals with projects. So it can find projects, for example, by a start date. So give me all projects that are more recent than some date. In the backend, you would probably query some database or do something like that to fetch this. So presumably you already have code like this. It does some business-related thing that you do. So the only thing required to, well, not the only, but the most important step to expose this over GraphQL using Speaker is to somehow make this method chosen, let's say. So the most explicit way, and the one that I'll stick to for the purposes of demo because it's so obvious, is annotations. But it's absolutely configurable. You do not have to use these annotations. They're just sort of the easy way. So let's say I annotate the method and say I'd like this to be a GraphQL query. So from there on, you can start creating your schema. Schema is basically the thing that you fire the queries against. So this is what you query, actually. So in order to get an executable schema, all you have to do is register this object with annotated methods that we would like exposed. And that's it. You register the instance and you generate the schema, and from there you can create the actual GraphQL runtime object. And that's it, actually. This is all you have to do. Now you can start querying it. So you could have a query like this, as we said, a project and code legendary, and it has description and tasks and the things you're interested in, and then you can execute immediately this. So you can call GraphQL.execute, give this query as a string, and you will get a result back. And this result you can then serialize to the client, and that's it. You're done. But let's get more interesting. This was super vanilla setup. We have one-to-one mapping of everything, so that was a bit too easy. Let's say that, so we have this query that we would like, but let's say our projects are crowdfunded, for example. So we would like to also be able to get the current the current funding. We want to see how much our project got. Imagine like a Kickstarter or something like that, and you want to see how it's doing. So you would like to be able to add a field here, of course. So in your backing code, you probably have something like this. You have a project class that sort of corresponds, at this moment, it corresponds one-to-one. So you have a project and, you know, standard getters and whatnot. So you would like to be able now to get a current funding. So you would like to be able to do something like this, add a field here. So how would you do that? How would you assemble this as a graph? Well, you could, you know, just add another function here that talks to Kickstarter API and make a web call, but I hope you notice that that's a horrible idea, because now this simple domain object that project is suddenly is making web calls and has business logic and stuff like that, so that's horrible, so don't do that. So instead what we can do, we have our service class as it is, and then we can nest a field like this, for example. This is a way to assemble an actual graph out of our API. So what we can do is we can create a new query called current funding, and using this magical annotation, GraphQL context, we mark project as the context of this new field. So basically this field becomes nested into the project as if it was actually nested in the class, like on the previous slide, but without that ugliness. So now your business logic is where it should be. It's in the services, and that normally talk to third-party APIs and so on. So you do it that way. Of course, you know, this is only half of the story, because, okay, we now know how to expose our Java code as GraphQL API, but there's still things left undecided. For example, how are you going to handle the web part? You still need to set up an endpoint. You still need to somehow accept the queries and the variables and whatnot from the client. You need to send the results back, and of course, this needs to be done in a certain way so that any client can talk to you in a uniform way, and there is a specification for GraphQL over HTTP as well. So you would need to implement that if you want to be compliant. So if you're doing this with Spring, we also have a Spring Boot starter that makes this pretty much trivial, I would say. So, you know, you just add a Maven or Gradle or whatever dependency. This is still in very early development, reflected by the current 0.0 something version, of course, but it's pretty usable, I would say, already. So you can mess with it if you like. You add a dependency to it, and that's pretty much all you have to do. And from there on, any Spring managed bean can simply be exposed as GraphQL API using the GraphQL API annotation, for example. So you sort of just mark it like that. So this is a normal Spring service. You say, I would like this service exposed. Then you mark the methods you like exposed as well. Again, not necessarily that way, but that's the most obvious way. So you can do it, for example, like that. And that's it. You don't have to do literally anything else. You just start the application. You don't write any web-related parts. You don't do anything else. Just start this application, and it will serve GraphQL. But let's say, for example, that the class you would like exposed, like this project service, isn't in your control, perhaps, so you can't slap annotations to it, or, you know, like the GraphQL query annotation, for example. So, of course, you can do the regular Spring stuff. You have a configuration class, and you create a bean and whatnot, so you can also put the annotation there. But because you couldn't annotate the specific methods you would like exposed, you need an alternative way. So the logic for this is in a class called Resolver Builder. So Resolver Builder chooses what gets exposed as a resolver function. So here I'm customizing it. So I'm saying for this project service, I'd like to use the public Resolver Builder, which just exposes all public methods. You could, of course, have a custom one that, you know, exposes only certain methods based on some custom annotation that you have, or on naming scheme or whatever. So you would, yeah, do something like that. So demo time. Let's see that in action with Spring. So just give me a second to mirror my screen. Yep, okay. Let's see, is that big enough, or is it legible enough? Can you read it properly? More or less. If I zoom a little bit more. I guess it's good now. If you still can't see, complain, please. So here's my project service. It's pretty much what you would expect from the slides. It's a standard Spring service annotated class. It has some methods inside for working with projects. It can find the project based on code, or it can create a project. Notice the annotation here, mutation. So mutation in GraphQL is pretty much the same thing as a query, but it also causes an effect on the server. It's not purely fetching data, it's changing stuff. So logically, it would be an equivalent of maybe a post or a put call in REST terms. So I say there's a mutation for creating projects, there's a query for fetching a project by ID, or for looking for projects based on tags, for example. Here's the current funding query that you might remember. So it's nested inside a project, and here it won't do, what's this? Okay, no idea what this is, I'll just move it. So, thank you. So here I'm not talking to Kickstarter, obviously, I'm just generating a random number, but imagine it's talking to Kickstarter and getting your current funding or whatnot, or doing whatever you need to do. So that looks like that. There's a task service for pretty much similar things. It's also just annotated with GraphQL API, and it's working with the tasks. So, it can create a task or update a task or whatnot. Now, let's see. So that's pretty much it. The GraphQL specific things are these annotations. That's it. I don't have literally anything else. There's no web part at all. You can see all the classes on the left. There's nothing GraphQL or web related at all. It's just domain objects and repositories and services. Very simple stuff. So if you start this application, there's a little also interesting thing that you can do. If you add a property like this, GUI enabled, it will enable a graphical environment known as GraphQL Playground that allows you to interactively play with your API. You can fire queries, you can test it and do stuff with it. It also comes as a standalone application, so that's not even necessary, but let's see how it looks like. So by default, the endpoint will be /GUI, and then you get this nice environment for testing out stuff. So it has autocomplete and everything you might expect because it already knows the types and it knows everything. It knows all the queries that you have available. It knows everything, so it can already help you with that. So as I said, it's also packaged as a standalone Electron app, so you can also use it that way without this built-in thing. Okay, so let's start. Maybe I should change the theme on this to get it more visible. Let me see if I can do that quickly. Theme dark, I guess. If I say light, that will do something. Indeed, okay. Is that more legible? Cool. All right, so let's start doing stuff. So I'll restart my application so that it's in blank state. Okay. So we can start doing stuff. So on the left side, you can see all the sort of queries that I prepared. So I'll run a mutation to create a project. So I say create project with name legendary. Again, it's a dairy shop. I am assigning an owner of the project. In my case, there's just an ID of the user. I have some hard-coded users. And I'm just choosing the first one as the owner of this project. And I'm assigning some tags. So it's a shop and it's dairy. And then when I create a project, I want the code and the current funding. Somehow it already has current funding. And the tasks back. So I'll create this project. I run it here. I get it back. So of course it has no tasks. We just created it. It has some randomly generated funding. It got assigned the code. So this is what I get back. So now we can start. We can create a task on this project. So in similar fashion, I can create a task calling this mutation. For the project ID, project code that we just received. So I'm creating a task of buying a cow, because that's important for a dairy shop, or maybe almonds, people milk almonds these days. And the type of this task is purchase, so I need to purchase a cow. And I would like the code and the status of this task back. So I create a task, and what I get back is the default status, which is planning. If you don't provide a status, then by default it will be in planning. It got some generated code back. So now I have a task. So let's list our available projects. So I have this query here for listing projects. So it will give me all the projects. It will get their code, their tags, their tasks, and then from tasks it will get some stuff as well. So let's run that. Okay, so I get my one project that I created. It has the tags that I put there and so on. So there's another interesting thing here, apart from the queries and mutations. There's a thing called subscription. So this is also something defined by GraphQL. What a subscription is a way for your server to send push notifications to the client. So you can also enable this feature. You can say that, for example, here, I want to be able to follow a task so that any changes to the task are immediately pushed to me. So, you know, if you have a web page or something, that you can subscribe, of course, to that and then listen and then update your UI as events occur. So here I am subscribing to task status changed for the task one, the one task that I created. In the GraphQL spec itself, there is nothing describing how you actually send these notifications to the client. So that's up to you, but there is a specification put together by the Apollo guys. Apollo is by far the most used client, JavaScript client for GraphQL. So in order for the client, of course, to know how to work, they put a specification, and it's based on WebSockets. So you need to open a WebSocket, and it pump the events through there. And then, of course, the messages need to be in certain shape and all that. But the Spring Starter that I showed you will automatically take care of that for you as well. So you can just start using it. So you can say, I'd like to follow a task. So here now it says it's listening. So in different tab, I can change the status to, for example, work in progress. So I'll run that. And then here I will immediately get notification. So I received this. So task 1 is in status work in progress. So I can move it to done, for example. Oh yeah, you can see here, I can do autocomplete. It will tell me everything. This is an enumeration, so it automatically knows what are the possible values here. So I can run, now it's done. I get notified, and so on. So the way this is done in the backend, this is maybe the only tricky part here, how the notifications are, how the subscription is implemented. So the way it's done in GraphQL Java, you need to return a publisher. So, you know, if you've maybe attended the talk today or just know from, this is the reactive stream publisher, the standard one implemented by all the reactive libraries like RX or Spring Reactor or Java 9 itself. So you already have this, but of course that doesn't tell you much. So how do you create this? So because this is a Spring application, the way I did it here is I created a Flux, so Spring's implementation of publisher. So I created a Flux, and I basically get a subscriber that I simply store. I have a map. Well, it's pretty much a map. It's a map of lists where I keep all my subscribers. So I just keep the subscriber for later on dispose, meaning when nobody subscribed to it anymore. So when the client terminates the connection or stops listening, like I did in the Playground client where I just terminated it, it will remove itself from the subscriber. So it looks very scary, but this is quite basic actually. Yeah, because reactive streams have a backpressure strategy, my strategy here is to simply drop overflow and only send the latest events. Okay, so that's pretty much it when you subscribe. And then I have a mutation for updating tasks. So when I update a task, okay, so I get an existing task. I check if client provided a new description. If so, I update it. Status is mandatory, so I update the status as well. And then I notify the subscribers by simply fetching the subscribers listening for this task and then calling next, so standard stuff. So I just basically send the next thing. And that's it. That's the part you need to do. Of course, this is somewhat simplistic, but it's also more or less realistic. You can react to mutations, for example, from one client to send pushes to the other client and so on. Yeah, so that would be one way. You could, of course, you know, subscribe to some system event, to a Kafka stream, or to God knows what in a similar fashion. That's the part you need to do. What's taken care for you is starting a WebSocket, implementing the specification, how the messages should look like, and so on. There is even a keep alive thing that's also implemented and so on. So there's quite a few more interesting things that I can show you, but this is more or less just a teaser really, because it's just a half an hour talk, but I'll give you some ideas of what you're in for. There is also an optional specification for paging. So it's optional in the sense that, well, your server doesn't have to implement it if you don't like to, but it's a standard way to do paging. So it's cursor-based paging, but of course you can interpret the cursor as offset and then do normal offset and limit style paging as well. This is exactly what I'm doing here, actually. So you can see here, for example, I accept an integer that is a limit and an integer that is an offset. And you can see some customization going on here. So you can use this annotation to change, well, I'm not changing the name here, but I could if I wanted to change the name of the argument and then give it a default value as well. So I'm giving it a 0. And yeah, I just make sure you don't pass anything funny here. So it takes regular values, or well, non-negative values. And internally, it looks like this. So normally you wouldn't just create a sublist like I'm doing here. You would query your database with limit and offset and, to do paging and things like that. And there's a helper that can help you to turn a list of results that you got from the database into this page object that's necessary. Yeah, it's create offset based page, but basically it's up to you. You can create this page object any way you like. And if you do that, if you return a page, then you can ask for a bit more complex queries. So I'll give you an example of that. I have one prepared here. So I'll just fire that up. So I would like to now ask for a page. So it looks like this. So I give the limit and offset. Okay, as we said, offset is optional. It will be 0 by default. And then it works this way. So you have a page info object that tells you if there's a next and a previous page, and then the edges are the actual results. Well, actually, the nodes are the actual results within the edges. So that's the project in my case, because this is a page of projects. And so I am asking for code and name, for example. So if I run this thing, I will get a result as you may expect. So, oh, sorry, I ran different. I should have ran this one. So, yeah, so I get a page info and it says that there is no next page. That's because we only have a single project and I asked for 2. There's no previous page either, and the edges are the one project that we have. So that's one way to do paging. Another perhaps interesting thing is if you're using, let's say, interfaces, GraphQL also has a notion of an interface. So I'm mapping this Java interface to a GraphQL interface. And I say that I want all the implementations automatically discovered, which means that despite my API only ever using the interface, it never mentions the implementations anywhere. So if you see the project object, it only mentions the user as the owner. So there are 2 implementations of user, being company and person. So you can have like a legal entity as a user, for example, or a person as an owner. So yeah. That's another way you can do things, and what this gives you is the ability to make queries that are conditional on the type of the result. So you can do things like this, for example. So you can say, yeah, I have already one. Doesn't matter. So I can ask for projects, and then I can ask for owner. And then depending on if the owner is a company, I would like company name, but if the owner is a person, then I would like their first name, things like that, so you can even branch based on type and so on. So that would be pretty much it. As I said, it's mostly a teaser because there's plenty of more topics to cover, like how do you do security in this context, how you do caching in this context, because you can't do just simple REST style, cache based on URL and things like that. So there's plenty more topics. Of course, Speaker will help you with all of those, but to learn all that stuff, please attend my talk on Wednesday, which would go into common problems and solutions to common problems in GraphQL. It's called Your GraphQL Field Guide, and that will be pretty much it for this one. So with that, I'm closing, and you have about half a minute for a question, but of course you can just hunt me down later and ask more stuff.